All our dreams can come true if we have the courage to pursue them. Walt Disney. This is Isaiah. Isaiah is 24 and recently finished his high school equivalency. While he was in school, he worked with a friend learning how to be a carpenter. Isaiah has heard that there are openings for carpenters with a company that will be working on AdultEdMed. Isaiah would like to join this company so he can finally be a professional carpenter. The interviewer greets him. He says he's heard Isaiah is a hard worker, but reminds Isaiah he'll need to take a quick paper test to show he knows his stuff before he moves to the next stage of the interview. Isaiah thought he was done with tests, but many companies use entrance exams to sort applications to find qualified applicants. Isaiah knows what he's doing, but he has to show that to the interviewer. Isaiah puts that aside and prepares to use the knowledge he got from completing his HSE and working with his friend to pass this exam and move on to the next part of the interview. It isn't long before Isaiah is faced with an old frenemy: fractions. Fractions are an example of a rational number, and rational numbers are used throughout the carpentry field. A rational number is any number that can be written as a ratio of two integers. A ratio is a comparison of two numbers, while integers are the set of positive and negative numbers. For example, look at this picture. How many chairs are at the table? How many people are there? There is a ratio of 6 chairs to 3 people. Put another way, there are 2 chairs for every 1 person at the table. This is a ratio. We write such a ratio as 6/3 or 2/1. The order we say the numbers matches the order we said the words. We said chairs to people, so we wrote the chair number first. If we wanted to say people first, we would use the people number 3 and end up with a ratio of 3/6. Fractions are a particular use of ratios. The top and bottom numbers each tell us something slightly different. The top number is the numerator. It tells us how many there are of the thing we are counting. For example, 3 chairs at the table are being used. The bottom number is the denominator. It tells us how many are in the set or group. In this case, there are 6 chairs at the table, so we can say the denominator is 6. This leaves us with the fraction 3/6. Much like how we could simplify the ratio earlier, we can simplify the fraction. 3 out of 6 chairs are being used. 3 is half of 6, so we can simplify this fraction to 1/2. In this example, there are 5 parts to the block, but 2 are shaded in. If we wanted to count the shaded parts, we would say the fraction is 2/5, or 2/5. 2/5 is sometimes called a proper fraction because it's less than a whole, and the word fraction itself means less than a whole. In this example, there are 10 parts to each block. 1 block is fully shaded in, so that's all 10 parts shaded out of 10. The other block only has 5 parts shaded. That's 5 out of 10. If we put those together, we get 15 out of 10. 15/10 is called an improper fraction because it's more than 1 complete set, so it's more than a whole. An alternative is to simplify the fraction. Since 1 full block of 10 is filled in, we can call that a whole and call it 1. And since 5 is half the size of 10, we can say that 5 out of 10 is the same as 1 out of 2, 1/2. Fractions can be written in 3 ways. Proper fractions have a numerator smaller than a denominator. Improper fractions have a numerator equal to or bigger than the denominator. Mixed numbers use a whole number with a proper or sometimes improper fraction. Most carpentry work starts with mixed numbers. Before he begins, Isaiah remembers some basics of working with fractions. To add or subtract fractions, he remembers that he must always use common denominators. This means finding equivalent fractions that have the same bottom numbers. To multiply or divide fractions, the fractions must be in proper or improper format. To change between mixed numbers and improper fractions, Isaiah remembers that each whole number represents a complete set, while the denominator describes how many are in the set. Therefore, by multiplying the whole number by the denominator and adding to the numerator, he can get an equivalent improper fraction. For example, if I have the mixed number 1.5, I can draw a line to cut the 1 into 2 parts. Then I can count the parts, 1, 2, 3. I have made both blocks into units of 2, and 3 are shaded, so I have 3 halves. Isaiah looks at the problem he was given and thinks about what he is being asked to do. He has been given a set amount of wood, from which some is removed. He needs to determine if he can make a certain amount of blocks of a given size from what is left over. Thinking carefully, Isaiah recognizes that this is a multi-step problem. The first step will be to subtract the 2 5/8 feet from the 4 feet. The second step will be to multiply 3/10 by 5 and compare the amount he needs against the amount he has left. A good problem solver, Isaiah thinks about what kind of answer they are looking for. In this case, they are looking for a yes or no answer. So how does Isaiah know what action he is supposed to take? What words clue him in? In fraction math, reading for keywords is very helpful to solving a problem like this. Perhaps you've seen a word list like this. It's very helpful, but it's perhaps more important to think about the concept. If you only look for keywords, you may miss what is happening when those words are not used. In the first part, because some of the wood is cut from the 2x4, we can understand that it is being removed, which is a subtraction action. In the second part, because there are 5 blocks all the same size, there is a multiplication problem. They then asked us if the blocks can be made. This will only work if the amount of wood left is greater than the wood required, which is a comparison. Now that Isaiah knows what is happening, he must solve his problem. He must subtract 2 5/8 from 4 feet. Isaiah thinks back to his rules for subtraction of fractions, and he remembers the phrase, common denominator. Before 2 fractions can be added or subtracted, they need to agree on a common denominator. This is because the denominator tells us the size of the pieces being added or subtracted, while the top number tells us how many are being added or subtracted. Look at this example. If I add the blocks on the top to the 2 blocks below, how big is my final piece? What do I call it? Because the answer is unclear, it is necessary to first decide on what the size of the pieces are, and then the operations. To find a common denominator, you need a common multiple between 2 numbers. For example, 2/3 and 1/2 have denominators of 3 and 2. A common multiple is one that they can both multiply to be. 2 times 3 is 6, which makes 6 a common multiple. Often there are smaller numbers that work, called the least common multiple, but multiplying the denominators together will produce a quick common denominator. Once a common denominator is found, the numbers need to be adjusted. The numerator and denominator are like 2 sides of a coin. What you do to one, you do to the other. Because changing 3 to 6 is doubling, we need to double the 2 in 2/3 as well. The same with 1/2. We multiplied 2 by 3 to make 6, so we multiply the 1 by 3 as well. Fair is fair. In Isaiah's problem, he is subtracting from a whole number. What is the common denominator for a whole number? Isaiah pictures each foot separately, like it was already its own board. He's going to need to take 5/8 of a foot from one of those boards. This helps him understand what he's going to need to do. He borrows one of the feet of wood and turns it into 8ths so it matches what he has to subtract. That gives him a board with 8 out of 8 pieces, or 8/8. He can then subtract 5/8 from 8/8, leaving him with 3/8. Then he can subtract the whole numbers, in this case the whole feet. This means he subtracts 2 from 3, leaving him with 1 whole foot with his fraction of 3/8. Isaiah has finished the first part of his multi-step problem. After making his initial cut from the 4-foot plank of wood, he knows he has 1 3/8 feet of wood left to work with. The second part of the question was, can he still make 5 blocks 3/10 of a foot long from what he has left? For this, Isaiah will need multiplication. If he needs 5 blocks, how long would 5 blocks of size 3/10 be? He can visualize them stacking together. The size of the piece doesn't change. Multiplying the 3 by 5, he'll have 15 parts of size 10th. That's a fraction of 15 tenths. A block of size 15 over 10 is more than a set of 1 of 10. So Isaiah takes 15 tenths and converts it to a mixed number. He can see that he has 1 foot and 5 tenths of a foot. Since 5 is half of 10, he knows this simplifies to 1/2. He needs 1.5 feet to make all 5 blocks. But he only had 1 3/8 of a foot to work with. Isaiah now realizes that the answer to the question is no. He cannot make the blocks and finish the job with 4-foot 2x4s. Isaiah continues through his test. Eventually, he comes to this question. Because the question asks, how many, Isaiah recognizes this is a division question. He also uses mixed measurements. Isaiah remembers how to divide fractions by fractions. In this example, 4 circles are being split into 2/5 chunks. That means after dividing each circle into 5 parts, how many sets of 2 can you make? 10 sets of 2/5 are created out of 4 wholes. Isaiah remembers an important and useful rule for dealing with division. It's the same as multiplying by the inverse or reciprocal. This means the same number turned upside down. Isaiah repeats a phrase he learned in his HSE class. Keep, change, flip. He keeps the first number the same, changes the division to multiplication, and flips the second number upside down. Now he has a multiplication that will give him the answer much faster and easier than trying to count up pie slices. Isaiah is working with mixed numbers. To divide fractions, he needs them to be in impropers. Since a foot is 12 inches, he can rewrite his numbers as mixed fractions like this. Then he can convert the mixed fractions to improper fractions. This means that Isaiah can apply keep, change, flip to solve this problem. The 52/12 is the original size of the board we're cutting from. It stays the same. The division changes to multiplication. The 14/12 is flipped. The 12s cancel each other out, leaving 52/14. 14 goes into 52 a total of 3 times. 3 times 14 is 42. If we take 42 from 52, we're left with 10. This means that 52/14 turns into the mixed number 3 and 10/14. We can simplify this by dividing the 10 and the 14 both by 2. This leaves 5/7. 3 and 5/7 is our answer. However, what was the original question? How many planks of 1 foot and 2 inches can you cut? The 5/7 is not a complete plank. So that means we can only cut 3 full planks from the board. Sometimes construction calls for decimals instead. In this example, they wrote this problem using 22.5 inches. It's important to remember units when working with questions like this. We need to make blocks that are 22.5 inches long, but the original board is measured in feet. As with fractions, we cannot continue until the problems agree on a unit. So we need to either make the inches into feet or the feet into inches. So we'll start by making the 8 feet into 96 inches by multiplying 8 by 12. Now we divide the 96 by 22.5. It is often confusing for people what to do with the 0.5. One helpful approach is to multiply both parts of the problem by 10. This has the effect of moving the decimal point out of the way by moving it to the right. If you need to move the divisor more than one space, you can multiply by 10 as many times as you need to move it all the way to the right. In this case, we only need to move the decimal point on 22.5 once to get it all the way to the right and out of our hair. But when we do, we also move the decimal point on the 96 as well. This leaves a blank. This is fine because that's what a 0 is for. It takes up empty space. Now we can see how many times 225 will fit into 960. Multiples of 225 include 225, 450, 675, 900, and 1125. 1125 is too big, so we will pick the one before it. 225 times 4 makes 900. Isaiah can continue to find what decimal of a block he can make by adding more zeros, but he asked himself what the original question was. How many blocks 22.5 inches long can be cut from 96 inches? If he keeps going past the whole number, he won't find a complete block. He's found the largest number of whole blocks of the given size, 4, and can say that he's done. Isaiah is working hard to finish this interview exam, but his understanding of rational numbers will be a big help. Rational numbers are a major component of many careers. In real-world scenarios, he may need to make conversions on his own, and sometimes he won't have clear advice. For these situations, remember a solid problem-solving process is a big help. What is being asked? What information do I need to answer the question? What do I do with that information? Do it! Does this answer the original question? Do I need to keep going? Well done. With that out of the way, Isaiah is ready for the next stage of the interview. Soon, he'll be hard at work at AdultEdMed and making a name for himself as a career carpenter. And by practicing and remembering math basics, you can keep a fear of math from coming between you and your dreams.